Welcome back, Focus Learners. Let's jump right into it. Today, we're tearing down the engine of one of the most dominant forces on the modern web, React. We aren't just skimming the surface here. Our goal with this explainer is to completely demystify the so-called magic of how React internally renders the UIs we interact with every single day. We're going to pop the hood, look at the raw engine, and see exactly how it builds the web from scratch.
So what actually happens in that split second when you hit enter on a URL and a React site loads? It feels instant, right? Like the server just handed you a fully formed web page wrapped up with a bow. But actually, React's initial load is a brilliant illusion. What you're seeing isn't exactly what you're downloading.
With a traditional website, your browser downloads a massive HTML file packed with hundreds of hard-coded elements. Buttons, paragraphs, the whole shebang. But a React site, when you visit it, you're essentially downloading an empty HTML page. Literally just a single blank div with the ID of root. That is it. An empty container. But alongside that empty box, you are downloading a massive JavaScript engine. You might be pulling down megabytes of JavaScript just to render a screen with a few lines of text, because everything you eventually see is being built dynamically, right on the fly, by that engine. Here is our roadmap for this explainer. First, the rendering engine, then translating JSX. Third, component blueprints. Fourth, passing props. Fifth, state and repainting. And finally, the component lifecycle. Section 1. The rendering engine, building from an empty div. Okay, let's dive into this. To understand client-side rendering, let's look at the exact chronological execution. Step 1, the browser loads that empty HTML file we talked about. Step 2, it fetches the external libraries, specifically the core React code and React DOM, which handles browser-specific features. And step 3, well, this is where the magic happens. A function called createRoot targets that empty div. It essentially whispers to React, hey, this is your isolated playground. You control everything inside this box. From that exact moment, React uses pure JavaScript to inject and manage every single piece of UI directly inside that container. Section 2. Translating JSX, the syntactic sugar. Now, writing raw JavaScript to manually create hundreds of HTML elements, that would be an absolute nightmare. The code would be incredibly unreadable. So React solves this with JSX, or JavaScript XML. It's basically syntactic sugar that lets you write what looks exactly like HTML right inside your JavaScript files. It makes UI building feel supernatural. But the best part? You can inject pure JavaScript logic, variables, math equations, whatever, right inside those HTML-like tags using curly braces. It's this perfect marriage of logic and presentation. Even if seeing curly braces inside HTML feels, a bit like a developer's fever dream at first. But there's a catch. Web browsers, they have absolutely no idea what JSX is. Feed a browser JSX and it will just crash. It only speaks plain JavaScript. So there is an invisible middleman step. A compiler library, usually one called Babel, takes your beautiful, readable JSX and translates it into the dense, complex, plain JavaScript that the browser actually understands. So the browser runs the compiled code, but you get to write the clean, modern syntax. Section 3. Component blueprints, creating custom HTML. So we know how the code is written, but what about the architecture? Enter components. Think of them like custom, reusable HTML tags representing pieces of your site, a navbar, a button, a chat message. But React has very strict internal rules for these blueprints. First off, a component is just a standard JavaScript function. Second, the name has to start with a capital letter, Pascal case, so React doesn't confuse it with standard HTML tags. Third, it must return exactly one parent element. You can't just return two sibling tags, you gotta wrap them in a div or an invisible wrapper called a fragment. And finally, they're designed to be nested and reused infinitely, like Lego blocks. Section 4. Passing props, injecting the data. Having structural blueprints is awesome, but to make them dynamic, we use props. Props is just short for properties. Think of them like HTML attributes on steroids. When you write a component function, it takes one single parameter, an object called props, and this object holds all the custom external data you feed into it. Let's say you build a reusable chat message component. You can pass a unique message string and a sender string down into it as props. So one component renders hello from user, while the exact same blueprint renders hi from robot right next to it. Props are essentially how data flows downwards to bring your UI to life. Section 5. State and repainting, the interactive engine. Now, props are static.
So what happens when a user actually interacts, like clicking a button or typing in a box? Well, to get that, we need to understand the difference between a normal variable and React state. So the crucial point is this. In plain JavaScript, if you change a variable, the computer knows the new value, sure, but the screen doesn't change. React state, which we manage using a special hook called useState, is a totally different beast. State is data that is physically wired to the HTML on your screen. When that state data updates, React automatically updates the HTML to match it. It's an incredibly tight cause and effect loop. Step 1, a user clicks a button, triggering the state updater function. Step 2, React instantly detects that mutation. Step 3, React automatically recalculates and repaints that specific component's UI to reflect the new data. You literally never tell React how to update the UI. You just change the state data, and React handles the entire repaint process for you, automatically. Section 6, the component lifecycle, from birth to death. Let's look at the physical lifespan of these elements, because components aren't just static blocks. They are born, they live, and they die in 3 distinct physical stages. First is mounting. At 0 seconds, the component first appears and is injected into the DOM. Next comes updating. Whenever state or props change, the component re-renders its UI. And finally, unmounting. That's the moment the component is destroyed and wiped from the screen. React gives us a powerful hook called useEffect, which basically lets you hijack this timeline. It lets you run specific side effect code, like fetching data from a server or starting a timer, at these exact lifecycle moments. The secret to controlling this timeline is the uEffect dependency array. If you pass an empty array to uEffect, you are telling React, hey, only run this code once, exactly when the component mounts, which is perfect for fetching a product list without accidentally refetching it every single time a user clicks a random button. But if you put a state variable in that array, like a count variable, React will run your code on mount and every single time that specific piece of state updates. It gives you absolute surgical precision over when your code executes. And honestly, that brilliantly illustrates the elegant internal philosophy of React that we've been unpacking. React is fundamentally about breaking down a massive, complex website into tiny, isolated, reusable functional blueprints. It creates the illusion of a traditional web page by injecting these blocks into an empty div, and then it just operates as an automated engine. You manage the state data, and React handles the massive, heavy lifting task of repainting the browser screen for you. But of course, the engine is always evolving. Every state change triggers a repaint, and sometimes that means recreating components that didn't even need to change, right? Which can really bog down performance. But now, React 19 is rolling out a revolutionary new compiler that automatically optimizes your code to stop those unnecessary repaints entirely. No more manual performance tweaking. Which leaves us with a pretty provocative question. If the React engine is now smart enough to automatically halt redundant rendering, just how blazing fast will the next generation of client-side web apps become? It's a fascinating frontier for focused learners like us to keep exploring. Thanks for joining me on this explainer, and I'll catch you in the next one.